All right, next stop will be about the significant figures, which is really important in terms of measurement because it tells you about the accuracy of your measurement, of your equipment. Okay. All right. Before we get into the detail, I want you just to look at right here. So we have two rulers, and to measure the height of this Pikachu, just right on his head. Okay. So how tall is this Pikachu? Right there. Start from the left ruler. Okay. The ruler on the left side. What do you read? It's gonna be something. So let's say this is 5.5, right about that. That's halfway between 5 and 6. Okay. So this Pikachu could be somewhere between 5.6, 5.7, 5.8. I don't know, but it's totally above 5.5. Does it make sense? Okay. All right. Now go to the right side. Okay. So what's the height of Pikachu if you use the ruler on the right? Well, 5's right here. We have 5.5, 5.6, 5.7. Between 5.7 and 5.8. Okay. And what's the height then? Well, you can go whatever, like 5.76, 77, 78, 79, whatever, that works. All right. So here's the thing though. We want to take a look at this number. I'm going to ask you this question. So if you use the ruler on the left side, I just start with the ruler on the left side, you read 5.7. All right. 5.7 right here. Start with number 5 right here. Are you certain that this Pikachu is above 5 centimeter? Of course, right? There's 5 right there. This Pikachu totally is taller than 5 centimeter. All right. Now, what about number 7? Are you certain that this Pikachu is 5.7? Is at 7? Are you really sure? Not really anymore because we don't have the hash mark right here. We can't really tell. Could be 5.6, could be 5.7, could be 5.8. Okay. So in this case, we have a one certain digit, and 7 right here is uncertain. All right, we're not certain. All right. Now, if you use the ruler on the right side, right here, all right, start with number 5 and we read 5.78. Are you certain that this 5 is really 5? Of course, this Pikachu is so right here above 5 down here, right? So this is totally above 5, so we're certain. 5.7, we're gonna look at it closer. 5.5, 5.6, 5.7. So this Pikachu is right above 5.7. So we sure. Number 7, sure. All right. Are you sure that the last digit is 8? 5.78. Not really sure now. Could be 5.7, 5.78, 5.79. We don't have hash mark in between these two hash marks. Okay. So we're not so sure. Now, here's the definition of the significant figures. Significant figures contain certain digits. So how many certain digits are there? One certain digit, two certain digits, plus one estimated digit in a measure value. Okay. So this basically a significant figure could be as long as you want. Those are certain digits and plus one estimated digit at the end. All right. In the first case, on ruler on the left side, 5.7. So there's 2 significant figures. On the right side, if you use ruler on the right side, 3 significant figures. Now you can see the accuracy that on the right ruler is more accurate than the left ruler. Now Pikachu have to have the same height, gonna be the same. On the ruler on the left side, you can read only 2 digits. All right, one certain digit, the other one is estimated. The ruler on the right, you can read up to 3 digits. The first 2 are certain. The last one is estimated. Okay. So significant figures contain certain digits, as many as digits that you can, right? And then plus the last one is an estimated digit. All right, try right here. So what's the volume in milliliter of this water level? 1.1, 0.2, 0.3, 0.4, 0.5, 1.5, and something. Okay, so it's gonna be 1.5 and then something. You should have 3 digits there. All right, so 1.52, 1.53, 1.54. What works? It's fine. All right, so we sure that the 1, of course, is way above 1. We certain 5 is above 5 because 5 right here, 1.5. Right, and the last one we're not so sure anymore. This is estimated digit. So the for this graduated cylinder can read up to 3 suffix. Okay, so read the certain digit and then add one more. Basically, that's what you have to do. All right, now mass in pound. If I have Tusky stand right there, so how much does he weigh? We have 150, that's for sure. All right, 152. Is it 1, 2, 3, 4, 5, 6? Okay, so this is 1. So 152.1 and something, right? Because looks like this tip right here is go to the right past 1. Okay, so you should be able to read 152.1 and then whatever you can read. All right. So this scale allows you to read up to 5 sig figs. All right. So 1 for sure is 1, 150, 1, 5, and 2 for sure. All right. That's the first hash mark right here. The tip is past the first hash mark. So 1, that's for sure as well. And the last digit is estimated. So 0.10, whatever. All right. So 5 sig figs. Okay. All right. So one more time. So the definition of significant figure is certain digits, whatever, how many you can read, plus 1 estimated digit. Okay. And something that you need to know about sig figs carry value of subject being measured. For example, all right, this guy have put this object on the scale. 1, 2, 3, 4, 5, 6, 6 sig figs. Okay, the last one is estimated. The 4 is estimated. Now, this guy though, put on a scale, you can read 0.0280. In this case, there are only 3 sig figs. Okay, the first 2 we don't count sig figs because 1, they don't carry the value of the weight. The weight is right here, 280 right here, right? The first 2 it just serve as a decimal point. Okay, make sure to show that this is really small. Okay, and you say, what about the last digit? It's also 0. Well, 0 is 0, but it carries the weight because it's not 0.0281 or 282. This is 280. Okay, so the last digit carries the weight of this object. All right, I'll have you try. So how many sig figs are there? 4. There are 4 sig figs. Okay, the first one doesn't count. That's just a decimal point. Serve as to set the decimal point. The other 2 zeros that actually carry the weight of the object. So it's not 3120, not 3320. It's 3020. Right, and the same thing is not 2. It's 20, not 21, not 22, not 23. It's carry the weight. Okay, and always use scientific notation with the significant figure because it tells you the accuracy of your measurement. For example, like let's say this mineral weighs 96,500 grams. What does it mean exactly? So this could mean 2 things. If this measurement has 3 sig figs, you can write it like that, or could be 5 sig figs. It tells you the accuracy. These 2 measurements have way different accuracy. One of them is 100 times more accurate than the top one. All right. So here's a reason. If this number were to have only 3 sig figs, 9.65, the possible number, if you remember, so sig fig, the last digit is estimated. All right. The possible number could be 9.61, 9.62, 9.63, 4, 5, 6, 7, 8, 9. These are possible values. Okay, that's have some significant error. Compared to the number down here, 5 sig figs, the possible value will be just changing the last 0, not this 0. This 0 is a certain digit, right? Just the last 0 right here. So the possible number could be 0.6501, 0.6502, 3, 4, and 5. What's it called? The gap of error is much smaller than this. Look at how much it changed. 0.61 to 0.62. This one 0.6501, 0.6502, 100 times different. See that? So use scientific notation will tell you if the significant if your measurement is how accurate your measurement is. Okay, and the scale is so difficult to have scale that accurate, like 5 significant figures. In the laboratory setting, we don't have that actually. All right. All right, now let's do this. Just one more, just real quick with me. So, which number has the smallest and the largest at the highest number of significant figures? 3 sig figs, 1, 2, 3, 3 sig figs, 2 sig figs, and then 4 sig figs. Yeah. So this is 3, 1, 2, 3. This one 2. 1, 2, 3, 3 sig figs, and 1, 2, 3, 4, 4 sig figs. So the highest sig fig is D, the smallest is B. Okay. All right, next one. Which of these uncertain values have 4 sig figs? In A, there's 3 sig figs, right? 4. C is 4. Oh, forget B. B, 1, 2, 3, 4. These two just set the decimal point. 1, 2, 3, 4. So 4 sig figs, 4 sig figs. D could be 4 or could be 3. We're not really sure. It's not really scientific notation. Right? E, 1 and 2. So in this case, C and B for sure. I'm certain. For C and D have 4 sig figs. D could mean 5.420. 4 sig figs or only 3 sig figs. Not so sure. Okay, so always use the scientific notation. Well, in this case, you can add D. It's fine. But on the quiz or on the exam would be clear. I won't show you something like this. Okay. All right. Next one, we're gonna do operation on a significant figure. Start with positive and negative addition and subtraction.